Dear students, today we are going to discuss about optical add drop multiplexer. It is also called OADM, that is optical add drop multiplexer. It is an important component in the case of WDM, that is wavelength division multiplexing. See, first of all, let us see what is optical multiplexer. Optical multiplexer that is designed for using in the WDM systems, that is in the wavelength division multiplexing systems, and its main function is it is used to couple two or more wavelength into the same fiber. Similarly, in the case of demultiplexer, it is used to separate the different wavelength in a single fiber to different parts of the fiber. Okay, you can see here that this is a figure that is clearly showing the multiplexer and demultiplexer. Here different signals are at wavelength lambda 1, lambda 2, etc. up to lambda n that are coming from different fibers, that is different n fibers, and a multiplexer is shown here, and it is used to multiplex different wavelength to a coming from different fiber to a single fiber. So based on the selection lines in this multiplexer, the wavelength are coupled to this fiber. Similarly, if there is different wavelength at the fiber, then it will be passing to different fiber sections by using the demultiplexer. Okay, so multiplexers in the case of optical WDM systems that are used for coupling two or more wavelength into the same fiber. On the other hand, demultiplexer separates the multiplicity of the wavelength in a fiber and directs them to many fibers. Okay, so from this single channel, the different wavelength are coupled to different fibers. That is, here lambda 1 is coupled to this fiber, lambda 2 is coupled to this fiber. That means it is separated to different channels. The information contained in this wavelength is transmitted to different channels. And here in the case of multiplexing, different signals coming from different channels will be multiplexed to the same channel. Okay, that is the basic function of multiplexer and demultiplexer. Let us see. Next we will see the optical add or drop multiplexer or OADM. See, in the case of a point-to-point optical fiber link, individual wavelengths could be removed or inserted or routed to or add to that link for getting more flexibility in the optical systems. And for that purpose, we are using OADM. That means OADM is used in a point-to-point optical fiber link where individual wavelength could be removed or inserted or routed to add more flexibility in the optical systems. And OADM consists of mainly three parts, mainly three ports, that is input port, output port and add drop port. You can see here, this is a pictorial representation of an OADM. It consists of an input port, output port, and there is another port that is shown downwards, that is add or drop port. Suppose there are different n wavelength, that is lambda 1, lambda 2, etc. up to lambda n wavelength at the input. And in this case, we have to drop one of the wavelength. Suppose lambda I be the wavelength that is to be dropped. So we will use a drop port in the case of OADM. That means you can see here that this shows the OADM drop port. Here inputs are lambda 1, etc. up to lambda n, and at the output one of the wavelength should be dropped. So lambda I is dropped in the third port, and at the output port lambda 1, etc. up to lambda n is obtained except the lambda I. You can see here. That means at the output port all the wavelength lambda 1, etc. up to lambda I minus 1 and lambda I plus 1, etc. up to lambda n will be present, but the lambda I is not present at the output because it is dropped at some other channel. Okay, so the pictorial representation of this OADM drop function is shown in the figure. And next we can see similarly we can add a particular wavelength by using an add function in the OADM. That means when a wavelength lambda I is added, you can see here that a wavelength lambda I is added to this channel. That means it is by using the OADM add function, and it is pictorially shown here. That is here different wavelength are lambda 1 to lambda n, and here you can see at the input side lambda I is absent. So to this wavelength we are adding one more wavelength, that is lambda I is added, and it is given through different port of the OADM, and at the output we will obtain lambda 1 to lambda n including lambda I. Okay. So this is add and drop function of optical add drop multiplexer. Here we are adding one signal to the channel. In the previous case we are dropping one signal from the input. Okay. And the complete setup for the OADM is shown in the figure. You can see here that this is an optical link, and here multiplexer is there, demultiplexer is there, and similarly you can see here that there is an OADM switch, or we can say that it is a 2x2 switch, and here you can see that lambda 1 is dropped here and another lambda 1 is added here. So the complete setup of the OADM is shown in the figure, and here you can see that the OADM selectively removes a wavelength lambda 1, you can see here, and it then adds the same wavelength lambda 1 with a different data in the fiber. So you can selectively drop one wavelength and you can couple different data to that lambda 1, and then again you can add that wavelength to this channel by using a OADM switch or OADM add drop multiplexer. Okay, that is shown here. So next you can see the different types of OADM. Basically there are fixed OADM and reconfigurable OADM are there, and a fixed OADM are used to drop or add data signals on the dedicated WDM channels, and reconfigurable OADM they can electronically reconfigurable or alter the selected channel routing through the optical network. And basic specifications for the OADM is seen in this table. You can see different wavelength and extinction ratio, insertion loss, peak isolation, power handling, transmission axis, and fiber type and return loss, connector alignment, etc. are shown in this table, and wavelength is in the range 310, 1480, 1550 nanometer wavelength are used for OADM. That is light wavelength is used for OADM, and you can see the power handling is 250 milliwatt, and fiber is panda PM, return loss is 40 or 50 or 60, and these are the parameters of this OADM, that is optical add drop multiplexer, and this is all about this optical add drop multiplexer.